welcome to the webinar regarding submodels. It's a very nice feature in Powersim. You never actually need it, but it's very useful if you're using it. And I will show some of the features connected to submodels. In the introduction, we will look at the difference between the diagrams and a submodel. Many people actually think or believe that a diagram is kind of an isolated part of the model, but that's not true. You need to use a submodel if you want to isolate a part of the model. And that's also what you're doing. One similarity between diagrams and submodels, that is that the submodel is running with the same time steps, same advancements, and so on as the rest of the model. You cannot use tighter simulation steps in a submodel, like we could in a co-model in a very old constructor. So there are also some people misunderstanding that. Some people also ask, can we make an array of a submodel? Well, not of the submodel itself, but of course you can put arrays as input. So one submodel may be scalar, and a copy of the same submodel could be an array. That's useful. So where do you actually need the submodels? We will say something about that, where it's useful and so on. We'll look at the public and private variables. The fact that you can have private variables in a submodel ensures that it's never used anywhere else in the model except inside the submodel. There may be several diagrams inside the submodel, so you may use a variable inside there, but it will never be used in the parent model or above if it is not public. That's useful. Even in controls, you are not allowed to use a private variable. So I will also talk about linking an input in and out of a submodel. There are useful tools there. The connection points may also be used to link in and out. You don't need them. It gives a bit more clarity about which variables you're using inside the submodels. Also, in case you want an auto report, it's useful with the connection points. Then we come to connecting not only a variable to a submodel, but connecting two different submodels. If you have 100 variables and they have the same name, you can easily connect all of them almost in one operation. If they have almost the same name, meaning next point, underscore, if the output from one model has an underscore after the name, then the inputs may have an underscore before the name. And Powersim will still recognize the different variables and connect them to the correct one. The benefit of that is that you can have the same name on an input and an output, meaning you can make a chain of submodels or copies of the submodels. Then, if you want to make a general one, I will show a small function for that if we have time. Then also look at components, which is a way of storing a submodel. Actually, all models you are making, they are components. Even if you make a small bank model, it's laying under a component. That's what's above the simulation you have. So here in this model, I'm using component 1. But you can have several components, and that's a benefit in Powersim, because a component can be copied as a submodel into your model. You can copy from the same project, this one, or you can copy from another project, another file. Very useful. Then I will also show at last levels and flows if you have time. That's useful. You can actually use a submodel as a level, but add some functionality, for instance, an array sum or something. That's very useful. So let me show a very simple example of a situation you may have. If we say you have an auxiliary A, I call it here. This auxiliary A equals 8, for instance. We can make an auto report. This is a variable. If I want a copy of this variable, like this, then the copy will have a new name. Of course, because we can't have two variables with the same name in one diagram book. But I can if I put it in a submodel. In a submodel, you may have the same names as in the parent model. So you won't have this issue. It's no problem if copying one variable. But if I also have an auxiliary B here, auxiliary B equals 99, like this, and I copy both of these, like this, then I may have some work renaming both of these variables. So I don't want to do that. One thing I could do here is simply to copy these variables into a submodel. Then I keep the same name. So I will show that as a first test on a submodel. I make a model here. I call this one model X. Inside this model X, there may be diagrams. Currently, there are no diagrams inside this one because I've just created it. In the lower left corner, you will have a symbol showing if the model has diagrams or not. If it doesn't have diagrams, then you won't see it here in this tree view either. And this tree view, actually, to do all these things, you need the advanced user interface. So you should right-click somewhere in the menu or toolbar and choose advanced user interface to have access to both the submodel and the project explorer. I guess most of you already have that. So to create these diagrams and entering them, then you right-click and say Open Diagrams. Then I get in here. Now you see I got a small plus here in my Project Explorer. On that plus, I see my Model X. So here I can double-click on Share Diagrams. Then I get to Share Diagrams. Maybe here I want to copy these two variables. Then I can double-click Model X, and then I'm inside Model X. Currently one diagram, but I can add as many as I want. Here I paste my two variables, and as you see, I have auxiliary A and B. Let's now make one of these variables public. I right-click and say this one should be public. Now, this one is visible for the outside world. So I can, I'm now able to define this one equal to another value in the parent model. So let's say it's currently 8, but I don't want this 8. I want something else, not 3, 4, 5, but I say it should be the parent. Then I go to the parent model. Then I use this small tilde, maybe wrong name in English, this sign. That means I'm going upwards in my tree view. And then I put auxiliary A, for instance. Now you see the value is back to 8 because auxiliary A has the value 8. So I can view both of these simultaneously. Let me close all windows first. And I make one small window here showing this part. And I make another window showing this submodel X. Now we can see the content of this one. So if I now change this variable to 7, then of course this one changed as well, but they are two different variables. I can of course put another name here just to make sure they're different variables. One point here is that I can have the same name, but you should also make sure I'm not cheating here. So these are different, but they have the same value. Because this one is public. If I try putting the same definition as this one into this variable, then you see I get an error message saying that child variables that are not public are not allowed to refer to variables outside the parent. If you get this message, the solution is usually that you need it to be public. So I don't continue and I don't save that. But this is a bit inconvenient. First of all, I had to type this one myself because I don't have any linked variables here. Another issue, if this is a submodel that I want to do something in between here, perhaps this is an intermediate variable, and I want a resulting variable here. Result. Maybe the result equals twice of this b, for instance. Or, yeah, and I also make a connection from A to B, like this. Result is b multiplied by 2, and this b is A multiplied by 99, like this, for instance. Now I have some values here. Maybe I should rename this one to call it input. That's the input to my submodel, and so on. If we look in the root model on the shared diagrams, there you see I have a yellow mark on the submodel itself. Why do I have that? Of course, because I don't have a link from auxiliary A. So this one knows that it should have a link from here. Let's put that link there. And as you see now, it asks me, do I want to bind this to a child variable of model X? I could choose to do that. Or I could just create a link. Normally, this create link only will be selected by default if I already have a link. The reason for not doing that now is that we may improve this definition. Because the other issue of this, when using this submodel, that is that I'm now actually wasting my memory. Because I have this value that should have influence to the model X. Inside this model X, I would actually like a snapshot of this variable, but I can't have that between submodels. So therefore, we have this famous function ref. It doesn't say very much, but that's the function it actually wants me to put here. So if I drag this link again, even if it's already there, I'm allowed to put the link here. It will be removed immediately, but I get this connection wizard again. And if I now choose to bind this variable to this one here, then you see nothing happened except the shape of this link. We got this strange, it's not a delay, but it's a symbol saying that this is a reference between these variables. So if looking inside this one now, then you see it's now the reference of the auxiliary A in parent. That means they are actually the same variable. Even if names are different and so on, this is the same variable. And this is also the recommended way of connecting a variable to a submodel. You simply put a link there and choose a variable. Very easy. So if looking back to this one, this submodel I have here now, this model X, it has an input and it has a result and it has something happening in between. That in itself is a good reason of using a submodel, because this in between may in some cases be complex. You may usually have several inputs and maybe one output. In that case, it's perfect using a submodel, because then you make sure that these variables in between, they are not used anywhere else in the model. Maybe you want to use them, and maybe some other people want to use them, but you shouldn't allow them to do that, because maybe in some later version you want to change this intermediate calculation in some way, and then it's very nice knowing that this is not used anywhere else. Of course, you can look at the dependence list and so on, but it's much easier and much more clean to use a submodel. So that's maybe one of the important reasons. But there are other features as well and effects of this. You may want to reuse a part of a model in another part by copying a submodel. Copying a submodel is very easy. You simply copy it, and there it is. Now I have a copy of this model. Inside this copy, I can open diagrams or double click in a tree view. See here, I have the same model. This input is still connected to A. That may be a disadvantage. Maybe I forget that this one is connected to A. No problem, as long as I have this yellow mark. But what if I copied it to another diagram? If I had copied this submodel in here in the same operation as copying it, I did it directly here, then I don't see any yellow mark. But still, this input, it's referring to auxiliary A in the parent model. I will come back to this issue. That is one of the reasons of using a component rather than just copying a submodel. With a component, I could avoid this situation. I can actually choose which variables to lose their definition when I make a new copy. But for now, this is nice. If I remember it, I can have another variable here, my new value, like this. That has a value 2. And if I connect this one now to this copy of model X, then it asks me which variable inside model X do I want to connect to this variable. Then it suggests the input. It's actually the only public variable. So I say OK, and that's it. Now, if I look in the copy, this one, and you see this one is now connected to my new value. If I look at this now, I have different values than I have in the other submodel. And now 2 different values, because there are 2 different inputs. But this model, let me move it back to the original one here. This one uses this value. So we get 2 different results. Inside here, I forgot to make the result public. Of course, my result should be public. So I do that. I should have done that before copying the submodel. I make both of these public. Because now, let's look at these useful points before moving on. It's also useful not only for copying inside a model, but also for reuse between models. Of course, I could copy this one and paste it in another model somewhere else, because I need this procedure. It's much, much easier copying a submodel than copying a structure of calculations. Both because you need more variables, but also because you may wonder which variables do I actually need to repeat this calculation. So this is fine. To do this this copying, you can of course use copy paste, or you can drag it and use control key, just as you do with a variable. You can make many copies here, and all of them will be new copies of this model. Very simple. If you delete a submodel, then you will also delete your undo history. And you will get a warning about that. So if I delete this one, it says that you will not be able to undo this. Also note that in that case, you will not be able to undo anything else either. But of course, it's no problem deleting a submodel. Okay? Another situation where it's useful is if several people are working on the same project, the same SAP file, and one person could work on this one and one on another submodel doing something completely different, and it's much easier to merge when doing that. Then we should come back to that when we are connecting one submodel to another submodel. That's very useful. Okay, public variables, I've already mentioned, they're the only ones visible to the parent model. I have shown now how to connect an input to a model. What about outputs? If this auxiliary B should be equal to something inside here, then it is as simple as connecting the model X copy. Then look inside here on linked variables. You see I have the model X copy. I can't double click that one without adding something else here. So normally you don't double click that one, but you double click one of the children to this one. So if I double click input, then you see I get, I should remove 99, I get both the name of the submodel and the variable I connected to. Of course, in this case, I don't want the input, I want result to be used here. Maybe multiply it by 2 to do something. Then you see this has this influence to the variable. And of course, you could change this and so on. It's a very simple way of connecting. But you don't know here which variable, or you can't see it, which variable you have connected to. In most cases, you don't want to expose that either. But sometimes you may want to specify which variable inside this model X you are connecting to. If you want to do that, then you can use a so-called connection point. You can right-click here, say create connection point. I want a connection point here, for instance, and I want the result variable inside this variable, inside the submodel, to be my connection point. This is a list of all public variables inside the submodel. So if I do that, then I get 2 yellow marks here. One yellow mark says that this link is now not useful because this variable is connected to the result variable inside model X. Even if it's actually correct, it encouraged me to connect this link to this one in place of the model itself. Same with this mark. It says that model X copy dot result is missing. So I make this link, and then everything is fine. And again, note that this variable, it's not a variable in this shared diagrams, not in a root model. It is a variable inside this one. But I can show auto report and everything. So very useful if I want, if this is kind of the main result, from my model X, then that's what I want to do. I could make another variable here, calling that results equals 8. That's another variable. Same name, but this one is inside this submodel. This is not a link, it's a satellite connection, I think we call it. It just shows that this variable belongs inside this submodel. Okay. That was public and private variables. Linking an input. Then we got a wizard where we are asked which variable to connect to. When connecting the other way, from a submodel to a variable, using a result, then we get a list of all public variables on the linked list here. Or, of course, now I've connected to this connection point, then I only get this single result. Of course, I may want to connect to another one. If I do this, for instance, then you see I get both this one and the list of public variables. Currently, it tells me I'm not using this one because I'm using this link that I have from my result only. But double-clicking that one or the other one will give the same effect. You see, if I double-click result there or double-click result there, I get the exact same value in my variable. So that's very useful. I delete this one again, because it may be nice showing it like this. So, what if I connect not from a variable, but I connect an entire model to another model? Let's see what happens then. If I, for instance, make a connection between these two, then I do also get a wizard. And I get a binding ability. I could say that the target variable input should have something. I can choose to keep definition or connect it to input in this model or connect it to result. If I say now I want the source to be result, target input, like that. Maybe it didn't want me to do that. Let me see here. Oh yeah, it did. But I'm not sure why I got, I should remove that one. But, oh yeah, of course. Sorry, because I have this connection point here. Then I got this yellow mark. But I did connect it to the results of this model. But if I wanted to do that, I should, of course, have used this one. So I delete that connection point. I put this link back. And then you see I've got a connection here. So now inside my model X, I'm using the result from the copy of model X. When I did this, I did it only for one variable. I connected the output here to the result here. Normally, when connecting one model to another model, you may want to connect several variables. So I will show in a new model here. I make this model, which is kind of the source. Inside this source, I make at least two variables. I make my variable A equals 7. And I make another variable, b equals 9. So I have these two, 7 and 9. And they, I should make them public. Let's say they are two of many variables. In this case, I only have this. I could have a submodel only containing variables like this. For instance, I want to read from Excel, put that in a separate model, and say this is my input model. For now, it's just my source. I put that one there. So that source should be connected to another submodel. So now I make a copy of this one and say that this one is called calculation. And inside my calculation model, I also have variable A and B. And let me now, I go into variable A and I delete the definition of variable A for this one. So it's undefined, just to see what happens. Because this is actually a bit useful to lose the definition like this. You see here now, my calculation submodel is now undefined. That's the first one we had. If I point on this question mark, it tells me that bar A is not properly defined. True enough. Still, I want to connect this source to the calculation. And now you see my model looks at the names of my variables. So it asks me, what do I want with the target A? Well, I see that is undefined. I bind it to the source of variable A in the source model I have. And I want to do that for both of these. I could have had 100 variables like this, and it would recognize them by name. Since they have the same name, it suggests that I connect them. Of course, I could choose other ones here, but I want B to be connected to B, and so on. So I say OK to that. Then I have a connection here. Very quickly made connection. Regardless if it's 1 or 1,000 variables, it works. So if looking inside this one now, is it here? No, I cheat. Oh, it is that one. Yeah. So here you see the definition of the A variable here is that it goes to the parent, which is this model. Then it goes into the source, which is that one, and to the variable bar A. When going down, we use a dot, and going up, we use this tilde. So this one goes up to the root, then down to source, then into variable A. And it uses a ref function to save memory and time. Very nice. Same with variable B. Okay, so this is nice. But there is an issue also with this. What if I want an output from this one? I put these ones here. I have some calculation in between. And I want an output also named var A and B. Like this. Sorry, there. Something like this. This one, for instance, is some of them. And this one should be this auxiliary 1 times 2. And this one, auxiliary 1 times 3. Could have used some fractions perhaps, but now I want the output here to be var A. That's of course not possible. Var A has already been used in this submodel. So that's why we have these underscores. They are very useful to avoid this problem that we may want similar names on the variables. So I say here that since this is an output, I use an underscore on that one. Same with this one. I use an underscore after it. Underscore at end, implicit means that it's an output. Also do that for this one. Underscore before. Underscore before. That means this is an input. So now, if I take this calculation submodel and make a copy of it here, then when trying to connect this one, then I get these small arrows saying that in the target, my variable A is input will be binded to variable A in the output. And the fact that there's another variable A here is not a problem. So I say OK to that, and we have a connection. So this one, I get many windows now. If you see this one, for instance, it's got the value 160. If I repeat this again, like this, I connect them, just keep that. Then inside here, you see this one, it's 800. Something is now happening again and again for each copy of these ones. That is a very nice feature to work with. But again, we have the same problem. If I make a copy of this one into another diagram here, like this, then I get no yellow mark, no message saying that this one should have some inputs. Actually, this one now, it is using the copy, not using copy 2, not using anything else. It's using the copy because that's the one I copied. If we look in here, see this one, it refers to the copy. And maybe I want to refer to a completely different variable. I copied it in here in diagram 2, and that's not my intention. So this is a small issue. I think I will switch a bit on the agenda now. I would like to show components before looking at this general ways of building a model. So inside this one, what I actually would have liked would be if these inputs had been empty. Like that. That one, yes, it's empty. And same with this one. Just delete the definition. You remember I did that on another model a bit sooner here. Let me go back to that one before I show this one. In this one now, I have deleted the definition in a variable starting with an underscore. When I did that, I think it was in this model. I open it again like that. When I did it on this one, this is also an input, you see. If I delete the definition here, yes, then of course the link got yellow. And if looking at this question mark, it tells me, ooh, well, actually, it tells me what it tells me the same thing as I get in the other one. I'm not really sure why I got that message, but it's very useful that I get this message. It's the same as I get here. You see, it tells me here, it gives me a list of the variables being empty, meaning these variables, they should be defined. And most probably I should give some input to them. I should connect either another model or a variable. I should connect to these ones. So the easiest thing would be connecting a variable. What I actually expected here in this case was that it just should tell me that it has an undefined variable. But for some reason it managed to figure out that it needs to be connected, this one too. So that's fine. So going back here, I could of course define two variables. This auxiliary equals 55 and another one equals 67, like this, and I could connect one of them to each of this one. So you see here now, I have two empty variables, meaning there's no risk for me to say that this auxiliary one should be binded to variable A. So I do that. There's still a question mark. Variable B is missing. So I connect this one as well to auxiliary 2. This one is now empty. No risk of doing anything with it. If I bind it to one of the outputs, then of course there is a definition there. So then I will damage something. So the fact that seeing that this one is empty, that's a benefit. Also the fact that it will then show me that I need to do something with that variable. And now I'm back here. I can make a copy of this one again. And in place of taking two separate variables, I could connect both of the outputs here to the inputs to this one. So same kind of chain as we have here. But my point is now, I would like this copy operation to delete these definitions. When making a copy of this one, this copy, I don't want this yellow mark, even if it's useful, because it won't be there if I copy it to another diagram. And it actually makes this submodel being wrong until I've connected the correct input. Of course, I could connect it to this one, which currently is the case. Then I only need to create a link because these are the ones currently used. That's okay. It's no longer a yellow mark. But in any case, when making a copy, I would like these two variables to be empty, these inputs. Maybe only one of them should be empty, that I have a testing value or a default value, but then there should be a default value. I never want a reference to another submodel or another variable in a parent model when copying a submodel like this. So the solution to that is simply to make a component. So now my calculation here should become a component. Here is the one from my previous webinar, but I make a new one now. Normally when doing that, I save the model first, because it's a bit critical, this operation. So I right click and say add component. I add the component to my project. Click there, then you see I get a new component. I could call this one calculation, like this. Now I have this component in parallel to my current component. So in here I have a simulation and everything. I don't want to use any simulation inside this component. I only want to use the diagrams. And inside these diagrams, I'm copying the content of this submodel. I copy that into the root of my shared diagrams of this calculation component. When doing that, it's all question marks. Why? Well, that's because in this component here, there is no parent. So going into some calculation copy free variable A, this one doesn't exist. I used to refer to the parent here. So all this should be removed. And maybe I want a testing value, 9999. And same with this one. You see these arrows here. They tell me that these are outputs. That's because the source of my copy here, they are public. And when I make a variable public, it can be used for both input and output. And we use these underscores in place to distinguish between them. But on the root level, there you can't make any variables public. But here you can define if they have the transfer direction in or out. And that's something we normally do when making a component. So we put in transfer, same transfer direction as we use for our data sets. I double click, select both of them, double click them, go to advanced. Here we have transfer direction. If I choose in here, then look at this one, where I used to define if a variable is public or not. I now have the ability to define if it should keep the definition in a component copy. Meaning, if I make a submodel of this component, then I will not keep the definition in this case. So here I'm now in my component. I have now used test values here. Let's put some auto reports. These test values are used just to make some results here. Maybe I want this result to do some testing. Maybe I also want to test what happens if I put an array in here. So 9 and 9 and 12. Then I will get this result of my model. So I see my upcoming submodel, it works with these values. But no matter what I put in here, when I make a submodel copy, which I will show now, then it will delete this definition because I have not checked this mark. So let's try this. I go back to my original model here, and I want to make a new calculation. Maybe I should delete this one because I want that name to be available. Connect that one to the source in place, and then I say here that my calculation, this one, I click it once first to select it and give focus to this tree view. Keep a note on that, because if you don't do that, you won't be able to drag it. Then I drag it into my model like this, and there I have a copy of this submodel. And see here, I have the question mark. That's exactly what I want. The same way as I get the question mark, if I make a new auxiliary, I also get the question mark because it's not defined. No definition provided. For that one, I need input to A and B. Very simple. That input we got from here. like that. On this one, maybe I also want to use some outputs from this one and go in here and say I want to use the B result into this one. So it's pretty much the same thing, and by using components you get the ability, first of all, to test your variables. Here I've tested using some arrays, maybe do something with units, whatever, but the definition is deleted when I copy it. And that's pretty much the difference between a component and a submodel. So sometimes we don't need components, but if we really want to make them general, then we should do it this way. So then to my previous point, to make a general submodel. If we do that, of course, we now solve this problem with the lost links that are still available, but they're invisible if we go between diagrams. But how can we make a model completely general? As you see here, this submodel now, it easily handles the fact that one of the inputs is an array and the other one is a scalar. It also handles that this one could have 2 dimensions and this one scalar, but not 2 dimensions and 1 dimension, for instance. And one function I would like to show to you is a function where you can actually put 2 definitions into a variable dependent on some fixed values regarding this variable. And one fixed value is a number of dimensions. Is it a scalar? Has it 1 dimension, 2 dimensions, and so on? That could be very useful. So normally, let's make another variable for this. I'm still using the same outputs. I mean inputs here. I use that one. Should double click there. So I say here, let me show you with the if function first. I could say here that if my dim count, that's counting number of dimensions, because I want to this submodel created from the component, I want that one to handle any kind of dimension combination, for instance. So I say dimension count of the A input. If that one equals 0, then this auxiliary 2 should have the value 2. Looks a bit like a Z. Otherwise, it's an array, and number 4 looks like an A. So I give the value 444 if this is an A. You see now, this one, it is an array, therefore number 4. If I make a copy of this component now, let's make this one public. Here, transfer direction out, then it will become public in the copy. I'm not using that one, but that's okay. So I go to my model here and I make a component copy of this one, like that. I connect it to this one. These are not defined and so on. Connect them. And let's look at the connection point of this auxiliary 2. Then you see I got the value 2222. If now making a change, for instance, in here, where the A suddenly has another another dimension. I multiply it by 2 and 3, like this. Then you see in here, I got another result. Because now, this one, this is a copy, so I need to make the auto report. This is an array. Then I got this force looking like an A. That's because I suddenly now had an array coming in here. And it shows A for array. All this works fine. But what if I wanted an array as output in this variable? A completely different array, but I want an array in case we have an array coming in. Let's go back to the definition of the component. I go in here. You see, with an array, we have tested this now. It works as a component, as a submodel, everything. This one will change to 2 if I change this one to being just a number, like this. And you see it's 2. But if I go into this one and say that, okay, if it's a scalar, if number of dimensions is 0, and I use this value. Otherwise, I want an array here. I want 4, 4, 3, 5, 6, or 7 it became, like this. And, oh, actually this works, but let's make another array here. I won't forget the fact that I want arrays. I want to split this one as well. So I have 2 elements here and 5 elements in this one. If trying to do that, if the dimension count of a variable is 0, then I want 2 elements, otherwise 5 elements. And I get this error message, these dimensions do not match. If I continue then, this one is undefined. Because I'm not allowed to put one definition like this, otherwise this definition, I'm not allowed to do that in an if function. But there's another function similar to if, where this is allowed, and which is much more useful to use in cases like this. Because normally, in a larger case, if we have a dim count being 0, then we want a scalar out. If we have another dim count, then we want to use a for function, and maybe a for function with 2 dimensions if we have a multiple one here. So the clue is use this select function. You see the select function will allow this combination because the select function only accepts conditions that are fixed according to dimensions and so on. So they are fixed on the compile time of your model, meaning this one will only change if you change a range or the range definition and so on in the variable. So then it will, for the entire duration of the simulation, be either this answer or this one. This will never change during the simulation. And that's a rule here. We need it to be fixed during the simulation. That's why you use the select function. And then, if using select function, combine that with components, you have a very powerful system. The last thing I will show you. I'm sorry for going a bit over time here, but I would like to show public levels and flows very briefly what that's about. So, if inside submodel, if you put a level there and make it public, let's say that's the only variable. This level equals 12 hours, like this, reset, and I make this one public level. Then this submodel acts like a level. And what's the purpose of that? You can put the flow here. This rate equals 6. Now you see 6 here going in, and this is the time, so I need it's 6 hours per hour, for instance. Then you see I get some information here where this one is connected. I could have had 2 public levels, then I would need to choose. So this rate can now be connected to the model. And for instance, if this level had been an array, for instance, then I could have 2 outputs from this one showing the actual value of the level, including the array. The other one could be the array sum, for instance. And maybe you need some more complex function than that. It's very useful. Same inside this model. If I make a flow inside here, and I say this rate, let's say it equals 1, and I make this rate public, then I have the ability to show a connection point of this one. The rate connection point. This is not the same rate as this one. This rate one is in this parent model. This one is in the submodel. So you see here 2 different values, and I can run the model with this. I have some outputs and so on. Very, very useful. Another way of utilizing submodels. So thank you for watching. I hope you will enjoy this. I will send you the files, this test file. It's a really messy one, a spaghetti model, as we call it. But I hope it's useful for you. So you have some questions. I will quickly answer them. If you have 2 components, component 1 as a submodel in component 2. Yes. Well, actually, a submodel is a submodel, and a component is a component. So if, for instance, inside this component of calculation, if I make a submodel here, then that's a submodel. And it will be a submodel also when we make the component copy of this one. But your question, oh yeah, when you make some changes to component 1, it is not applied to any copies you have made. When you're using a component, like the one we did here, this calculation for instance, this is a copy. It's a copy of the component we have here. So if you make changes to this component, then you need to replace this one. Of course, we could say if it had inherited something, that would be nice, but it's also very easy to replace it, because if you delete this one, calculation, let's delete it, and let's say I have a new version now containing the other submodel, then you see this one is undefined, and all I need to do is to connect the inputs like this and the outputs going here, and this output is just able to needed to create a link like this. So then it's placed back. Since this component could be in another file, it would be difficult to determine, do I have the new version or not, or should it go looking for the new one? So it's partly by choice and partly because we haven't found a good way of doing this. We have discussed it a lot, of inheriting and inheriting on the fly, perhaps locking things. Because another issue with that, if we should have some automatic update here, what if you change this one, which is very useful to do? You may want to go in here, for instance, delete this submodel and maybe this variable, because you see there's no use of it in the outputs. And you have done some other changes here, and you have those changes. Then what if you change something here? And that should be automatically applied here. That would be a bit messy. So that's one of the reasons that we haven't really found a good way of doing that. That combined with the ease of connecting this, reconnecting it. Actually, sometimes we make a submodel only containing the inputs. Let's say in this case I had here, this calculation. Sometimes we make a separate submodel in between before the actual connection. Let me show you how to do that. Not even a component. I just make this one here, where we copy these variables. Actually, it's very nice being able to show this. I go in here and say in here, I want the variable A and B, but I want them both as inputs and outputs. So here I say it starts and ends with an underscore, like this. So with this one, now I can put this one in between at any stage. So I could connect these two variables to it and connect it further. Let's say I do that. I connect this one to variable A, and the other one to variable B. And then I connect this model to, which is my exchange thing. You see this A and B, they're both inputs and outputs, so they can be connected both ways. So in this case now, then if I need to replace this calculation, then I only connect it to or from this model, not from all these variables. So no matter how you twist it, it's very easy to replace a component where you have used it. Normally, of course, if you have hundreds of copies of it, it would be a bit inconvenient, but normally you won't have that. You would have a component where you make a model and you make the model work. If you have a new version of the component, you would normally be a bit careful by replacing it anyway. A rule says never change something that works. So there are some arguments for and some arguments against doing exactly that. Okay, I hope that answered your question. Another doubt, if you are able to open diagram in any type variable. Oh yeah. I haven't shown that, but let me show that as well. You can put diagrams into a submodel. Oh, sorry, into an auxiliary. Let me make an auxiliary here. And this auxiliary, let's say I have some advanced way of doing a calculation from this one here. So then I can right-click and say Open Diagrams. Now I am on the diagrams underneath auxiliary 4. In here I can put my advanced things. This A equals parent, and I need a tilde, auxiliary, what's it, 4? No, auxiliary 1. And I didn't get the tilde there. Auxiliary 1. So now it's just equal. And you see this one is not public. It's only in submodels we need public variables. When you put diagrams underneath a variable, then it doesn't need to be public. And you do some calculation. I won't do all that, but let's say you would need many variables. And this is the result. Result equals A times 2. Like this. Show some auto reports. You see 55, it comes in from this variable. Oh no, it was auxiliary 2. It came from this one. Let's keep it like that. Auxiliary 1 goes in there. And then we need to define the variable itself. And that is laying in the result variable, 110. That's now the value of this auxiliary. So that's the result. This one multiplied by 2. Of course, it would be easier doing it here. But now I've done that inside my diagrams inside this variable. That's also very useful. The difference between this way of doing it and using a submodel is that you can have only one result going out of it. And the fact that all variables are submodels, are public, I mean, and you cannot have any public levels and so on. Can't have those features, of course. So it's a bit simpler, but useful if you need only one result out. Okay. I hope that answered the questions. Any more questions now? I think I've answered all of them. So thanks a lot for listening. Sorry for the overtime, but I hope it's useful to use submodels. I really encourage you to use it. Have a nice day.